Last year we finally got the first real KNX RF Multi devices. For example, the ISE KNX RF Multi Radiator Thermostat. But what is KNX RF Multi actually and how is it set up? Well, this is what this video is all about. We'll take a look at KNX RF Multi. And with that, I would say hi and welcome back on my channel to this brand new video. So, as mentioned, in this video we'll take a look at KNX RF Multi. So I'll show you how it is set up, what's the difference to KNX RF, and we'll also take a look at the first KNX RF Multi devices. And that's because this video is made in cooperation with ISE. So we'll take a look at the KNX RF Multi portfolio of ISE, and in detail we'll take a look at the new Radiator thermostat. But before we jump into the EDS and create our KNX RF Multi line, let us first of all talk about what KNX RF actually is. Well, KNX RF stands for KNX radio frequency. So KNX devices that communicate wirelessly instead of via the green twisted pair line. So a typical setup is a combination of both a twisted pair installation and then in addition to that some KNX RF devices. So typically you have your normal KNX twisted pair installation, and then on the spots where you can't install a KNX twisted pair wire, you will use then KNX RF devices. What you'll need therefore is a KNX twisted pair to RF coupler, so a device that transmissions or that translates the KNX RF telegrams into KNX twisted pair telegrams and vice versa. And it's also important to know that you need to have this KNX twisted pair installation, or at least a KNX power supply with the twisted pair media coupler, because the media coupler basically opens or creates the RF network. As wireless is an open media type, we need a solution for that, and that's the so-called domain address or the domain. And this is created by our media coupler, which we'll also see later on in the EDS. And this domain address basically tells the RF devices you belong to this specific KNX installation or to this specific KNX RF installation. So each KNX RF network typically has its own individual domain address. So with that you can add devices without destroying your walls. So that's some fundamental knowledge about KNX RF. But what's now the difference between KNX RF and KNX RF Multi? Well, first of all, when we already talked about KNX RF, we talked about the already existing standard, which is actually called KNX RF Ready Mode. Now we have the KNX RF Multi Mode, and it's basically an evolution of the Ready Mode. And don't worry, it's backwards compatible. So if you have KNX RF ready devices, you can use it in combination with KNX RF Multi devices, but you need to make sure one thing, which I'll show you later on in the video. What is then KNX RF Multi for, or what are its advantages? Well, KNX RF mainly brings a higher reliability, acknowledgement and confirmations for telegrams, multi-channel operation, so not only the communication on one frequency, and in combination of these three advantages, the support for battery-powered devices with a longer lifetime. So let us take a look at each of those points, and don't worry, I'll keep the explanation as simple as possible. So first of all, multiple frequencies. In the old situation with KNX RF Ready, the communication only used one channel in the 868 MHz range, at least in Europe. In the USA we have another communication channel. And if that channel was blocked, well then basically no communication was possible. So it was either blocked by already communicating devices or by other systems, etc. But with this solution, you had the problem that if this channel is blocked, no communication is possible at all. Now with KNX RF Multi, Devices can use multiple different subchannels around the 868 MHz range. Now the devices can hop between those channels, so if one channel is blocked, the devices can use another channel. So the result is it's more robust, less downtime and less interference from other systems. Then the second innovation with KNX RF Multi are the acknowledgements. So with KNX RF Ready, the principle was applied fire and forget. What that means that if a device sends a telegram in KNX RF, it basically just assumes everything is fine and every device has received the telegram. Well, if it didn't arrive somewhere, well, too bad. There's no guarantee that those telegrams arrive at their destination. The result was, as you can see here in this example, if we have our RF actuator and some RF push button sensors, and the RF actuator sends its current state because it changed, well then some push buttons get this information and show it with the LED and some don't. Now with KNX RF Multi this cannot happen any longer because the receivers confirm that they actually got the telegram. And if a device did not confirm the reception, the sender can retransmit the telegram as long as every device has given a confirmation that it received the telegram. So when the parameterization is downloaded to the RF actuator, it now knows which devices received the telegram or should receive the telegram, and therefore it knows which devices should send their acknowledgement. And then we get to the third innovation, which allows to use battery-powered devices with a much longer lifetime. Because one of the biggest changes is that KNX RF Multi finally enables proper battery-powered devices that can both send and receive telegrams. But therefore, let's talk about why this is hard to achieve with wireless communication. Well, the problem is that if you want to have battery-powered devices that can both send and receive, you need to keep the radio receiver always listening, so always active, and that costs a lot of energy. Now KNX RF Multi optimizes that with, let's say, sleep strategies. What I mean with that? I don't want to go into much detail here, but what you need to know is that with radio telegrams we have a preamble. This preamble informs the devices, watch out, there is a message incoming. And that's what KNX RF Ready already had. Now with KNX RF Multi we have two different types of telegrams. We have fast telegrams and slow telegrams. Fast telegrams have a short preamble and then directly the message. With slow telegrams we have a much longer preamble. So the receiver here wakes up in the middle of this preamble, gets the preamble, sees that there are still missing 3 O's before the preamble stops and the real information starts. And because of that, he sleeps, because he now knows how long he can sleep before the information starts, and then he wakes up again to get the information. And because of that, the devices that get slow communication can sleep much longer than those devices that need to listen to fast communication. Now, to be fair, this is a very simplified explanation of it, but it shows the core principle of it. So what this means that if you have a battery-powered device, this battery-powered device typically sends fast communication because it wants to send his information fast so that he can sleep as soon as possible. But he receives slow communication so that he can sleep as long as possible for the receiving communication. So now you saw the innovations that come with KNX RF Multi. But what do you need now to use KNX RF Multi? Well, the core component is the media coupler. So if you want to use KNX RF Multi devices, you need to have a KNX RF media coupler that supports KNX RF Multi, like for example the ISE KNX RF Multi media coupler. What this media coupler then does is that it connects your twisted pair installation to the RF Multi network. It also opens up the RF Multi network via the domain address, And an additional feature is that it also supports secure proxy. So that means that you can have a secure KNX RF multi communication and then an unsecure KNX twisted pair installation. So this is how you can combine it then. And very important is that if you use a KNX RF Multi media coupler, then you can mix KNX RF ready devices with KNX RF Multi devices in the same project, because the media coupler handles the translation between fast, slow and those ready telegrams. But now I would say this was a lot of information, so let us take a look in the EDS on how we can use KNX RF Multi. So I'm here in my little EDS sample project, and what you can see here is that first of all I have my IP area, then in my installation I have two twisted pair lines, and within this first twisted pair line I have already created my KNX RF Multi segment. So just with the right click, add and then segments. Because this is another cool thing with the RF multimedia coupler, it also supports the segment coupler functionality, which basically means that you don't have to create an additional line within the area, but you can just create it below or inside of this twisted pair line. Because this was a lot of hassle before those segment coupler functionality was added, when you already had an existing twisted pair line and just wanted to add RF devices to it, you had to move this line up to the area, let's say address range, and then down below you could add an RF line. Now with the segment coupler functionality, this is no longer needed, because you simply can go inside your existing line and create such a multi-segment. And if we take a look at this multi-segment, here you can see this domain address, which in this case I have added manually because I have already a German video about it and I want to use the same domain address, but normally the EDS would generate a domain address on its own. And now we can simply add devices to it. So I'll open up the catalog, and in here I can search for IRC and then RF Multi. And then we first of all see the RF Multi TP media coupler device, which we need. So I'll add it into my multi-segment. And now you can see that it wants me to add the device certificate, because as mentioned, the RF multimedia coupler here supports KNX Secure. Now in my case, I don't want to use KNX Secure, because for the purpose of this video recording, it makes it a little bit longer to download the devices. So therefore I'll stick to the plain communication, but make sure if you want to use Secure, then simply enter the device certificate here. It also has the advantage that you can then program the device via serial number. So in a normal project, I would definitely enable this secure communication here and add the device certificate. Because I don't use it here, I'll click on later. And then down below, inside of this RF multi segment, I have two Radiator thermostats that I want to use. And so therefore, I'll add those RF multi Radiator thermostats. So the first one, and here again, I don't add the device certificate here. In a real project, I would definitely do that. And then the second one. And now here in my case, I want to have those segment devices, so those RF multi devices, in sort of one physical address range. Because normally, as you see here, they just use the next free address it sees in my installation, but I instead want to have it, for example, at the address range 100. So all the RF multi devices then start with the address 100. So the multimedia coupler 100, then the first radiator 101, the second one 102. And as I don't want to use the secure communication, I disable it here. So with that in place, we can now start to take a look at the parameterization. But in my case, I first of all want to download the physical addresses. And here another rule of thumb that you should definitely consider is first of all parameterize the system devices, then the normal devices. What I mean with that is first of all parameterize all your system devices like KNX IP routers, line couplers, and here in this case of KNX RF Multi, the TP media coupler. So I'll do that first. So click here on download, and then I can start to download the thermostats, which I'll quickly do. So I'll simply press the programming button in my case. And what you should know is I mentioned that you can enter the device certificate so that you can download the devices via serial number. However, for battery powered devices, you normally also have to press the programming button most so that you, let's say, wake up those battery powered devices. So that is something that you should consider or that you should know. So as you can see here, the devices are now parameterized. Now here for the second RF Multi Radiator thermostat, those two downloads failed because I was simply not patient enough or not pressing the correct programming button. But as you can see now, everything worked as intended. If we take a look at our segment, everything is parameterized. I see the serial number of it. So yeah, we can start to parameterize the thermostats. And so therefore I want to have the following, or I have the following situation. Those two radiator thermostats are both in one room. One of those radiator thermostats shall be the master device with the thermostat controller, and the other one should simply use the commanding value of the first controller. So let us parameterize that. Therefore, we take a look into the first radiator thermostat, into the parameters. And here you can see there already is a lot of information. First of all, about the device, so which EDS6 version you can use, secure compatibility, where you can find the labels, etc. And another cool thing is that if we go into the general settings, you can see here we have the context help. And if we open it, we can see we get some additional information. So if I click on those settings, we get some information about those settings here. Now, I wouldn't go as far as to say now you don't need a manual, but at least it makes it a little bit more easy within the EDS without the needs to always take a look into the manual. However, I wouldn't consider to throw away the manual. So let us start first of all here in the general settings. Now, as I already mentioned, the first thermostat I want to use as an controller. And here you can see, if we take a look at it, I can already set the settings, several thermostats in the room, which I want to check. And then I can say, is this first thermostat the leader or the follower? In my case, I want to have it as the leader. So this first thermostat has the room temperature controller that calculates the output, and this output is then connected to the other one. Then we have some diagnostic settings that we can enable. So for example, which I think is really important or is really interesting, is the remaining battery capacity. Then we have some informations or some settings regarding the display. Here we can set, for example, after how many seconds it should disable. We can disable, for example, the manual operation, because with the thermostat you have a little button on top of it, and there you can also, or the user can also set the set point temperature. So he doesn't need to have a visualization or a room or a display within the room. He could also use the button at the thermostat. And then we already have the settings of the main room temperature controller here. So first of all, the general settings, so which mode the controller should use after it was restarted. I typically then go into the standby mode. We could also disable the room temperature controller completely via an object. And then we get to set points. And there it is where it gets really interesting and where this device definitely shines. Because for a heating system or for a room temperature controller in KNX, we have multiple ways on how we want to specify the set point, specifically when we have other devices like push buttons or visualization that should also be used to set this set point. The two options are relative or absolute set point. The relative set point uses a basic set point temperature, and then via a group object I can specify how many kelvins I want to have the temperature higher or lower. So I can then say, for example, I want to have it 3 Kelvin warmer, which would then calculate into the set point temperature of 21 plus 3, so 24 degrees Celsius. Vice versa, if I want to have it 3 Kelvin cooler, it would be calculated 21 minus 3 Kelvin, so in this case then 18 degrees Celsius. And then the reduction for the standby mode and the night mode is also calculated based on this basic set point. So in this case, if we change the mode from comfort to standby, we would have the temperature 21 minus 2 Kelvin. So in this case, 19 degrees Celsius, in night mode minus 4. So in this case, 17 degrees Celsius. On the other hand, if I change it to absolute, you can see here we have absolute temperatures. So 21 degrees Celsius in comfort, 19 in standby, 17 in night. And in this case here, if I have a visualization server or a touch display, it wouldn't send a difference in Kelvin, but it would send an absolute value in degrees Celsius. That's the difference. And here I can't say, or I can't tell you which is the correct one, because you need to know which devices you want to connect to this room temperature controller and what they support. So do they support the absolute set point setting or the relative set point setting? Now in this case here I'll stick to relative. Then down below here I can set the range of which the user can decide on how many kelvins he wants to have it warmer or cooler. Then I can define, is this set point offset a 1 byte or a 2 byte group object? Again, here you need to know which device you want to connect to it to set it to the correct one. And then I can say the increments. Is it 0.5 Kelvin or 1 Kelvin? The only thing that is missing here, in my opinion, is the option to have it as a 1-bit object. This is also something that is sometimes seen on other devices. But besides that, you are pretty free on what you want to set up here. Then we not only need a set point, but also the current temperature to calculate the position. And so therefore here you can specify, do you want to use the internal temperature sensor of the thermostat or an external received via a group object. Now in my case here I will stick to the internal temperature sensor, but I would definitely consider using an external one because the radiator thermostat sits near the radiator, and so therefore the temperature is definitely higher there than in the rest of the room. You could balance it out via this setting here, but I would normally use an external temperature sensor. Here we can also specify when the device should send the current temperature onto the bus, and here it should be considered that you don't use a cyclically transmission, because then obviously the load onto the device and therefore also on the battery is higher, and the battery definitely won't last longer. So therefore I will stick here to transmission after modification and after at least a difference of 0.5 Kelvin, maybe also consider 1 Kelvin. So those are the basic settings. So therefore, let us hook that up to some group addresses, which I have already created. So here under heating, we have the office heating group addresses. So first of all, the current temperature, which we get here, the actual temperature. Then we have the current set point, so not in Kelvin, but the calculated set point. So we should have it here. Then we have the set point shift, and I'll just change it to the 2-byte value, and the set point shift status. So with this group address, a touch display visualization could tell the room temperature controller that it should be 2 Kelvin cooler or warmer, and here the room temperature controller gives us the current set point shift. Then we have the operating mode and the operating mode status. And then obviously we also need the calculated value, which we find here. So the command value. And with those connected, we can jump to the second radiator thermostat. And here it's now a little bit more simple, because in the general settings, we just say we want to have it as a follower, and you can see the room temperature controller is disabled. And the only thing that I need to connect is the VO, so command value input. So I need to connect it to the control value of our first radiator thermostat. Yeah, and with those connected, we can download everything and see if everything works as intended. But before we can take a look at that, we first of all need to do an adaptation run, because at the moment the radiator thermostats show the information IN for installation, which tells us do the adaptation run. And I'll simply do that by pressing the rocker either up or down for at least 3 seconds. Then you can see now the display changes to show us that the adaptation run is performing, and after that we can use it. So now, in order to take a look directly into our KNX RF network, I will use the new KNX RF Multi USB stick, which I'll simply connect to my PC, and then I can use it here, so KNX RF USB stick, and I can also configure it. And here, first of all, I should check for the correct domain address, where I can set it to the one in my project, because otherwise I wouldn't see the correct KNX telegrams. And then down below we can set to ready or to multi-mode. In my case here, I'll now stick to the multi-mode, and then I can close it, start the monitor. However, here I use my KNX RF USB stick, and then I'll open another monitor where I'll take a look into the twisted pair line. So down below here we'll now see the twisted pair communication, and up here the KNX RF communication. And if we take a look at it, we will see the fast communication. So what does that mean? Well, therefore, first of all, let me quickly filter for the addresses so that we see it a little bit clearer. And so let us go ahead and first of all, let's say we want to change the operating mode. So office heating operating mode, and I want to change it to standby, or let us change it to comfort, because at the moment it should be at the mode standby. So I go ahead and then click write. And what you should see now is that here we get the response, because as mentioned, we only see the fast communication. Here in this case, office heating set point, so the response from our battery-powered RF multi-device, because remember, battery-powered multi-devices send in fast communication while they receive in slow communication, and therefore we only see the response. So here we'll see the current set point and the current set point status. So I can go ahead and change this set point status, so this set point shift, and change it, for example, to 3 Kelvin. Click here on write, and with that you can see now the set point is 24 degrees Celsius, the set point shift status is 3 Kelvin, and the current control value is 26.7%. I can even go further to 8 Kelvins, click on write, and then we can see here the response. So this is what you should remember, that when you monitor KNX RF Multi with such a USB stick, you can only see one communication type or one mode, so fast or slow mode, at the same time. If you would want to see both, well, then you basically would need 2 USB sticks, one running fast communication, one running slow communication. Now, in order to see the slow communication, you have this button here on top, SLE. And with that, if I enable it, we can see now we run SLE mode, so slow mode. So if I now run the same telegram or send the same telegram, we no longer see the response from our radiator thermostat, but we see the telegram that was sent via the RF multimedia coupler in slow mode. And this is this button here on top. With that, we can change between slow mode and fast mode. Now with this running, let us jump back into our settings of the radiator thermostats, because I want to show you some additional functionalities. Because what else do we have? Because I now want to connect some additional diagnostic informations. So like, for example, the remaining battery capacity, the current fault state, and for that I have also already created some group addresses. So here you can see office thermostat 1 and 2. So here we have the current battery capacity, then battery low as an error message, then the keep alive group address, and this is something which I would definitely consider to turn on, because with that you can parameterize a functionality with an additional logic editor with which you can control if the devices are still alive. And this is here the in operation mode. And this is a bit that is triggered every 24 hours. So every 24 hours, this device will send a true to this group address. And with that, you can monitor if the device is still alive. Then we have the last fault information and the same for the second thermostat. So let me quickly download all my RF Multi devices. And you can see the devices are downloaded, and as my diagnosis tools are still running, we get here the informations. First of all, no error, which is pretty good. And here we get the current battery capacity. And you can see they are still at over 90%, and those thermostats are now nearly running 1 year. Now, to be fair, my demo installation is not running 24 hours a day. However, the thermostats are installed 24 hours a day, and you can see they are still at over 90% battery charge. So I can definitely say that the battery lifetime is pretty good with those KNX RF Multi devices. So those are here the diagnosis information. And then there are still some additional functionalities in the room temperature controller that I want to show you. So I'll go ahead into the parameters. And down below here we can enable those functions. So first of all, status, presence detection, boost function, frost protection, summer winter operation, and scenes. Let us start with the status. Here we get the information of the current operating mode, and there are some additional data types in which this operating mode can be sent. That is useful for some external devices. Now here, as you can see, I didn't connect the correct operating mode because I haven't connected it. So I'll quickly enable it here, and if we take a look into the group objects, this was definitely a fault on my side. You can see I connected the operating mode status, so this group address, to the priority, which is definitely not correct. I want to connect it to the active operating mode. So here we have the state and here we have the preset. So this connection was definitely wrong. Then we have the presence detection, which is pretty cool. So here I can either use a presence button or a presence detector. The presence detector basically just then is a 1-bit object that I can connect to my presence detector, and then the operating mode is automatically set to comfort. While with presence button, I can have a comfort extension by, for example, 60 minutes and so on and so forth. Then we have the boost function, which I think is pretty cool, because this boost function simply means that I'll get a 1-bit object, and with this 1-bit object, if I trigger it with a true, then the thermostat valve will go to 100% open for the predefined type of, for example, 30 minutes. So if I go into a room and it's way too cold for me and I don't want to change the set point temperature, etc., I can simply click on the button, then the boost function is activated, and after 30 minutes it goes back to the real room temperature controller state. Then the frost protection is something similar, but the other way around. So here I can go into the frost protection mode via a window contact. So when the window is opened, then with a delay of 5 minutes, the temperature controller will go into the frost protection mode. So that it doesn't unnecessarily heat up the room. Or I can do it via a temperature drop detection, which basically means if I don't have a window contact, then I can detect it via the temperature sensor. So if the temperature falls down, in this case with a threshold of 0.4 Kelvin with the time range of 1 minute, so that means if a temperature drops down from, for example, 20 degrees Celsius to 19.5 degrees Celsius within 1 minute, then it will detect it as a temperature drop and goes into the frost protection mode. Now here in my case, I'll stick to the window contact. Then summer winter operation is something similar, but in this case I would connect it, for example, to a yearly scheduler, so that in the summer period where I don't need the heating system, it will stick to frost protection mode, and I can't override it via, for example, a push button or the visualization, because this object then has priority. In my case, I don't need it, so therefore I will disable this function. And last but not least, we also have scenes, and with these scenes I can then go into a specific operating mode. So if I, for example, have a scene in my office, which is called work, I can press the scene, my light go into the predefined state, and my heating system would then go into comfort mode. So you can see this room temperature controller has a lot of functionality. And yeah, basically the only thing that I am missing is the 1-bit object for the set point shift. But besides that, you can see it's pretty versatile. And even though we only used ISE devices for KNX RF Multi in this video, there are still other devices out there available. So for example, from the company BSS, there is a KNX RF Multi window handle that you can use. And this is definitely a perfect combination with the Radiator thermostat. So I could go ahead into the parameters, enable the frost protection via the window contact, and then I have added the window handle into my installation. Here you can see the window contact group object. However, this device can give you much more information if you take a look at those settings here. So you have the information, is the window open, is it tilted, is it locked, etc. However, I only want the information opened or closed. So I'll hook it up to the group address, frost protection window status. And with that, if I download everything and I now open up this window handle, you can see if I go to my thermostat that it's now in frost protection mode, because we can see the set point is now 7 degrees Celsius. So this is how you can also combine multiple RF multi devices with each other. So what's my conclusion about KNX RF Multi? Well, I'll definitely have to say that I think it's a cool addition for the KNX RF world. Now, to be able to use proper battery-powered KNX RF devices is definitely a great addition, which I think was missing, especially such a radiator thermostat. And as you saw within the EDS, it's basically nothing new, because the RF devices or the RF multi devices still are handled like normal KNX devices, because they are basically normal KNX devices. But now I'm interested in your opinion. Have you used KNX RF, and now especially KNX RF Multi? Write it down in the comment section below, and also what you think about the new KNX RF Multi devices. So without further ado, I would say that's it for this video. If you enjoyed the video, consider a like and don't forget to subscribe to the channel to not miss out on any new videos. So with that, I would say I'll see you in the next video. Bye bye.